ECHS Calculus with Michael Sifo. Solids with known cross-sections. So first of all, let's talk about the volume of solid revolutions. As you may have already learned, we can calculate the volume of solid revolutions with the integral from a to b of pi times the function squared. As you may have noticed, this is the exact area of a circle, which is calculated pi r squared, with r being the function. Cross-sections, however, are simply just the integral from a to b of any shape's area, which means the volume of a solid revolution is also a cross-section. And a cross-section can be anything from a square, a rectangle, or a trapezoid. So, let's get started with an example. What is the volume of a rectangular cross-section perpendicular to the x-axis, whose height is pi and the base is the area bounded by f of x and the axis in the interval 1 to 4, is the base of a solid? F of x equals sine pi x over 2 plus 2. Before we do any of our calculations, let's try and remember all of our known information. First, we know that f of x equals sine pi x over 2 plus 2 between the interval 1 to 4. We also know the shape of the cross-section, which is its rectangle. And the area of a rectangle is base times height. With that, we also know that base is f of x and height equals pi. Let's start with our calculations. We start off with the integral from 1 to 4 of pi sine pi x over 2 plus 2 dx. We can then pull out all known constants and give us the integral from 1 to 4 of f of x dx multiplied by pi. With that, we can then follow with the fundamental rule of calculus, which gives us the antiderivative, which I'll be saying as capital F of x, which is going to be pi times capital F of b minus capital F of a. We know that the antiderivative of f of x is negative cosine pi x over 2 times 2 pi plus 2x. And we know that b equals 4 and a equals 1. Now, after the fundamental rule of calculus, we'll be getting pi times negative 2 over pi plus 8 minus 2. We then distribute the pi, and we are left with negative 2 plus 6 pi.